Hello, everyone. Thanks for joining our Immersion Day session. Um, and uh, we'll wait for a minute or so before the folks get started. And I'm also joined by some of our team members. We'll go through the agenda as follows. Okay, so let's get started. Today, uh, we're going to discuss about how to run SQL Server workloads on AWS. Thank you again for your interest in attending these deeper dive conversations, which are immersion days. Again, hopefully, with all the times that we are living in with the COVID-19 and these usually these type of sessions are happen in person, and we are trying to we as the entire technical evangelists and technical community is trying to adjust doing these sessions virtually online because there are also some lab components and there are some usually these are done in person and we are trying to make the best of how do we engage different folks across the time zones. Um, a little bit of background about myself, and I'll let Raj continue with some of the conversations. So before we get into the introductions, I wanted to share about what these sessions are and what is the value that's going to provide for you for joining, right? Typically, these immersion days will give you a jump start on a specific topic. So the topic that we are going to cover is the SQL Server. There are a lot of customers trying to run the Microsoft workloads, moving into cloud, the AWS being the leading cloud provider. The lot of customers looking for, is it better to run as is it better to use some of the managed services? What are the options of running SQL Server on AWS? Is it better to migrate from SQL Server to some other data store? So we'll be touching the different topics today, and it's a combination of again presentations. We wanted to make it as interactive as possible. Feel free to ask any question and answers. Take this as a learning session. We are here to help. And again, even after the immersion day, so we'll share our contact details. So if there are any further questions, we can definitely you can definitely reach out to us for any specific questions and how to make this work. A little bit about myself. I'm the CTO for NorthBay and been with NorthBay for over 5 years. And I was fortunate to work for AWS before I joined NorthBay. And I helped a lot of the initial lighthouse customers, what AWS calls, including the in life sciences, pharma, including the financial services, where I have helped migrate their initial workloads, including a lot of Windows workloads and SQL Server workloads. So before that, I also worked for Oracle for 7+ years, helping the customers in the data database landscape, both OLTP and OLAP and different types of workloads. So I'll hand it over to Raj to give a brief introduction about himself, and we can walk through the agenda as we go. Thank you.
Thanks, Lakshmi. Hello, everyone. This is Raj Harjika. I'm a director of technology at North Bay. I've been in the industry for almost 25 years. Ex-Amazonian, like Lakshmi. So it was a good experience to work for AWS. I have my experience primarily falls into enterprise architecture, and so helping businesses like banks or healthcare or financial domain or insurance domain for that matter, and helping them for their business transformation, digital transformation, and for last 6-7 years, cloud transformation. So that's what I have been doing. My role starts generally with the vision document and taking it to efficient operations environment and helping the company walk through their roadmaps and whatnot. That's what I have been doing, and that's a little bit about myself. And I'm glad to be here today to share my knowledge on SQL Server with all the participants. I hope you guys can see my screen. If anybody has an issue, you can write it in the chat.
Yes, we can see your screen.
All right. So the first topic what we have today is SQL Server on AWS. I'm pretty sure being in IT, you must have come across one sort of database engine or another, be it SQL Server or Oracle or DB2 or Sybase for that matter. And all these databases in the past has been existing pretty much on premises, right? Because of a lot of different reasons. It may be privacy laws, it may be compliance and things like that. Over the years, things have changed, and people have started migrating their workload to AWS, to cloud provider, I would say, be it AWS or any other cloud provider for that matter. But our focus, we are premier partner for AWS, and our focus has been, doing the best consulting and being a trusted advisor for our customers on migrating any sort of workloads to AWS, and SQL Server is one of them. So there are a lot of different reasons why people are moving their workload from on-prem SQL Server to AWS. Some of the key factors or key benefits of going to cloud is, of course, as we all know, is cost optimization and the manageability and the admin. The licensing model is different, which is very important. So there are a lot of different reasons why people are moving. And then if they are moving their applications workload, which is tied up with SQL Server, it makes sense to move the SQL Server as well to AWS, mostly with keeping the performance in mind. So what we are going to start with is how does SQL Server fit in AWS? What are our different options to go with, things like that, and then we will let's see the agenda, what we are going to cover. So we are going to cover selecting the right service. There are different services offered by AWS for SQL Server migration. Then selecting the right instance. Instance is nothing but you can, in layman term, you can say it's a type of machine or a configuration of machine. What we will talk about, what is Amazon RDS, that stands for Relational Database Service. Then we will talk about how to secure your SQL Server workload on AWS. What are some of the things you can do for monitoring the performance? And then we will talk about scaling and optimization. There are concepts like auto scaling and all. In traditional old days, we used to do vertical scaling, horizontal scaling, and we had to worry about all sort of configuration and deployment and security. All those things are well taken care of when it comes to AWS. At the end, we will be doing an hour lab. So that would give you the opportunity to do some hands-on and to get a feel of how does it look, how does it fit in AWS world. Okay. Any questions? Let's make it interactive. If you have any questions, please type it into QA option in the menu bar, and either myself or one of the panelists would be more than happy to answer those questions. All right. So selecting the right service. I'm not sure that if you do have a good background in AWS, but in a nutshell, AWS offers two types of services. One is managed services. One is where the customer is responsible for managing their service, right? So selecting the right service is the very first thing you want to do when you are going with any sort of migration, and we are talking about SQL Server. Same thing applies to SQL Server or any other workload for that matter, that what sort of service you are looking for. Are you looking AWS to manage your service, or you want to be responsible to manage your workload or the service that you are using? And we'll see what those options are. Okay, there is a service called Amazon RDS, that is Amazon Relational Database Service, which is a part of a managed services offering from AWS. The other option is SQL Server on Amazon EC2. That EC2 stands for Elastic Compute, and EC2, you can think of a machine is assigned to you or given to you where you will have your SQL Server running. Okay, some of the key benefits, I would say, is that when you go with managed services, you don't need to worry about the things what you see here in orange: scaling, high availability, database backups, database patching, database installation and maintenance, OS patching, OS installation and maintenance, power outage, and things like that. So all these things are taken care of by AWS because you are using a managed service that is Amazon RDS. All right. On the other hand, if you go with SQL Server on Amazon EC2, you can think of this as a machine, again, a server given to you, where scaling, high availability, database backups, database patching, installation, maintenance, OS patching, all these are your responsibility. AWS will not be held responsible if anything goes wrong with your database backup. So you need to come up with your own strategy, how you want to do backup restore, how do you want to make sure that the database is going to be highly available, because that is the requirement of any any application for that matter. It doesn't matter how big or how small the application is, but you need to make sure that your system is highly available and scalable. So as listed in the bullet points here, consider RDS first, because you get rid of a lot of overhead as far as maintenance and management of the database is concerned, right? Focus on business value tasks. Of course, when you are not bothered too much about administration side of things, then you can focus on how you can add business value with the data what you have. You can focus on things like machine learning, AI, or analytics and things like that. High level tuning asks, so it's not, you don't really need to worry too much about going low level tuning, because that's all part of things like auto scaling and multi-region deployment or multi-zone deployment. And one of the things which you should note here is that these all are configurable, right? So it's not that things are hidden from you. You can see how it is going to be scaled. You can see how it's going to be highly available, right? You can see how the configuration of database backups are configured, right? So how the backup restore is going to work. So it's all visible to you, but at the same time, it's all done by Amazon RDS. Schema optimization. I would say this is a bit tricky as far as AWS Managed is concerned, because when you are working or enhancing your application, schema is something which you need to work on. So I would say it's a blend of effort. It's not solely that AWS will manage your schema optimization. It would optimize what you currently have, right? But if your design or architecture is poor, as a data architect, if you have not done a good data modeling, this won't really help, right? So that's something that you need to keep in mind. No in-house database expertise. That's an interesting one, because people still will say, if I'm a DBA, I will be out of job. No, that's not the case. People still need, human intervention, human expertise, no matter how automated the system is, right? So it's good to say no in-house database expertise, but you do need to understand how these backups are going to be done, how the restore will work, how the disaster recovery will work, how the high availability will work, so how the data model will look like, right? So I agree to an extent, but not like no is a very strong word, right? So that's something which you should be aware of, that still there is skills needed. From executive standpoint or people in finances, it may make sense that, yeah, okay, so we don't need any database skill. No, that is not the case. You still need people who understand database, who understand database architecture, who understand things like, how does it work in on-prem, how does it fit in AWS, things like that, right? So don't get scared. It's just to highlight the benefit. On the other hand, if you go with SQL Server on AWS EC2, you will have full control. As I said, like the things which are in gray boxes here, they all have to be taken care of by your database person, DBA in general. So DB instance, backups, replication, clustering, these all are the things that you need to worry about. Options that are not available in RDS, right? So anything which is not part of ongoing enhancements in RDS, you will need to worry about, because EC2 you have the full control, not AWS. It's up to you how do you manage it. One thing I would like to highlight, which is not really explicitly mentioned in the security aspects we will talk a bit later, but I just want to highlight that security is something which still applies. You still need good security people who understand data security. How does it work in data which is in rest? How does it work in data which is in transit? Things like that. So security is still falls, I would say, partially with AWS and partially with customer managed, right? So if you have done things on EC2, you need to worry about things, and we'll see what that means. So far, so good. One of the panelists, can you see what the question is, and if you can reply? All right. So this is a high-level view of what is supported on RDS and what is supported on EC2. Again, keep in mind, RDS is something which is a service offered by AWS, and EC2 is an instance or a server with different type of configuration available offered to you. Okay, so as far as RDS is concerned, the versions are listed here, 2008 onwards till 2017. EC2, you can do pretty much everything because you have the full control. That's the key reason, right? Addition supported. In RDS, we have Express, Web, Standard, and Enterprise. Amazon EC2, it says all. Pretty vague, but it says do whatever you want, pretty much. High availability, AWS managed. In EC2, you have to manage it. Always on and mirroring are different options that you can see in the dashboard. Encryption, different mechanisms are there. The traditional TDE is supported, which is offered specifically for SQL Server. And then we have a different mechanism of storage in using AWS KMS, which stands for Key Management Service. And this is common for both RDS and EC2. Authentication wise, either you can go with Windows authentication or a typical SQL authentication mechanism. Backups, managed automated backups. Again, as I said, so backups, restore, things like that are automatically taken care of by AWS RDS. In case of EC2, you have to use, come up with your own plan. How do you want to do it? How the restore will work? Or if you are not expert in those areas, you can use third-party tools as well. And some of the third-party tools, keep in mind, is also offered by AWS Marketplace. So you don't really go and do a Google for this. You can first look in AWS Marketplace, and I'm pretty sure you should be able to find something there. Maintenance, automated software patching, then again, on EC2, it's self-managed, right? One of the things which I have experienced in my 7, 8 years in cloud transformation with some large organization, that automated software patching is good, but still you need expertise within your team, people who understand how does it impact your current application workload to be specific, right? Because there may be certain code written or some things which are written, which because of this patching may fail. Because keep in mind, we are not talking about AWS managing your application, right? So it all works together. It's all integrated, so it has to work all together. So keep in mind that whatever patching is going to come up, they notify you well in advance, and generally it is done during your maintenance window. So it doesn't come like you wake up one morning and the things are all patched up and updated. They notify you in through different channels, be it your dashboard or your email and whatnot, right? But in EC2, you do the patching when you want. Even if you want to keep running, patch 0.1 and patch 1.0 is the latest, AWS doesn't care because it's self-managed. Make sense? All right. Let me know, guys, if I'm going very fast or if the pace is all right. Okay. Again, we are getting some into more details. Choose the best service for your needs. What you really need. So from the RDS, as you can see, SQL Server can be both in the environment of AWS RDS, or it can be on Amazon EC2 instance. If it is going with RDS SQL Server, so it's a managed physical infrastructure, managed DB install and backups, managed OS and patching. We talked about this already, managed high availability and scaling. So in SQL Server EC2, managed physical infrastructure, you still get that. You still get managed OS installation. You still get managed scaling, and then OS level control, right? One of the things is that, when it comes to physical infrastructure, because we are going to cloud, that's a default thing which is provided by any cloud provider, right? So physical infrastructure, like anybody can physically go into my data center and play with my data. No, that is not possible, right? And that's one of the features offered by pretty much all the cloud provider out there. Okay, so you don't need to worry about those aspects. So as I said, if you use RDS SQL Server, your responsibility includes app optimization and tuning, deployment orchestration, right? So how do you want to deploy it? It's up to you, because even though our RDS is going to manage it, but if you have your deployment model is not defined or architected well enough, things may not work the way you want it. I have seen things even on RDS not performing well. In fact, one of our customer has approached us that they have done all the best things, best practices, but still the application is performing very poorly, and we have to get back to them with our assessment and see what the things have gone wrong. And generally and it's a mindset of the people, when they say that we have migrated our database to cloud, it should work much fast, 10 times faster. It should do all sort of high throughputs and whatnot, but that is not realistic, right? Your database may be best optimized database in the world, but if, as I said, if the application is architected poorly, if the application is deployed poorly, it won't really make much of a difference. You will still run into the issues. You will still have transaction issues. You will have all sort of database related issues you can never ever imagine, right? So make sure that it's still going to RDS doesn't mean that everything is going to work as per what is listed here, right? That, okay, my application is on cloud and I'm all set. No, that doesn't work that way. Okay, we are talking only focusing on AWS RDS, and there are other services which can help you to optimize your application and all, but that's not scope of this immersion day. All right. SQL Server, Amazon EC2, your responsibility: app optimization, deployment, monitoring and recovery, high availability, backups, DB, and OS patching. So when I look at this responsibility list, it's pretty much what we do on-prem, right? So doesn't make much of a difference from the admin standpoint. From the database standpoint, still the same thing, not much different. But when it comes to RDS as a service, it makes quite a difference as far as admin task is concerned. So when you go talk about RDS SQL Server, it's a cloud native solution. It focuses on business value task, right? So you focus, as I said, more of turning the data into information. It's less admin work, less management, right? So it's a very high level tuning task. Pretty much all the options are given to you either in drop down or checkbox, but you should know the meaning behind it, right? So don't go overexcited on the things which are given to you. Schema optimization, as I have already explained, that schema optimization may work if it is already architected well, but if you're making major changes to schema and things like data pipeline and other stuff is not properly done, it may still not work the way you are expecting it. Last bullet point I won't mention because I don't like it personally either. But I am in a strong believer that you can't get rid of people who have database skills, because that is very much still in need. There may be some business case where you can't really use RDS. Maybe you're bound by licensing, or maybe some other reason the application is so tightly coupled that you need the full control. In that scenario like that, you would choose EC2, right? And then you have everything to be done by you. AWS is not going to worry about it. So if you need control over, as I said, DB instance or OS, backups and replication, clustering, sysadmin role, that is DBA, you still will go with EC2. Need to use feature size or performance options not available in Amazon RDS. So if you want to do things which are specific to SQL Server and it's not part of RDS as a service, you can, EC2 is the way to go. Generally, the approach what one should take is that, workload assessment is very important. At North Bay, we have a lot of expertise and we have done it for, I don't know how many customers. I don't have the numbers even. I don't remember numbers, I should say. That we do a lot of cloud assessment where we go as experts and evaluate what the customer is running and what they are doing and what their business goal is, right? For what they are expecting from a given workload. We do all sort of assessment, be it cloud adoption, be it migration readiness, things like that, where we come up with the best recommended approach given the business case or use case, and then we decide whether we go with RDS SQL Server or we go to EC2. Right, so there may be features which are specific to SQL Server and not offered in SQL Server RDS, then of course go with EC2. Okay, and one thing do keep in mind when it comes to EC2, it's not just installing it on one server. I have been emphasizing on the word backup, replication, or high availability. Keep those factors in mind if you're going with EC2 and if you're doing the architecture or design. Make sure your database can work in a highly available environment. It can get deployed in multi-AZ or multi-region deployment, depending on what model you're following, and do a lot of testing. It's because testing is applicable, I would say, in both. to be honest. That's my personal experience. People say generally, oh, we have gone to RDS, we don't need to worry about performance testing and all that, stress testing and all. I would say I don't agree because, as I said, migrating to AWS doesn't mean that you are going to get what AWS as a company offers, right? So you have to make sure that you're doing the right thing from the very beginning, and then only you can achieve the performance and everything what is given as a metrics to you as a customer. Some of the other aspects for SQL Server EC2 versus RDS. In case of EC2, license is included. Bring your own license is allowed. Full control over the instance. Automated backups, no. Self-managed always on availability groups, yes. AWS managed multi-agent deployment is only available for RDS. Okay, so AWS managed, right? So if it's customer managed, you can do it on EC2 as well. So one of the key reason why people are moving SQL Server to AWS RDS is a licensing model as well, right? People in traditional way, people are generally logged in for databases or their whole infrastructure or the platform for years, right? With companies like IBM or Oracle or Microsoft and whatnot. So they're trying to get into a better licensing model, and RDS does offer that. If you're interested in getting some more details, we can definitely point you to some URLs where that is detailed out there. Selecting the right instance. So as I said, selecting the right instance is the key, because if you are not selecting the right instance, your database may not perform the way it is expected to be. Okay, so it's very important. Some of the features or factors what we look for when we are deciding for database instance, I would say, of course, the compute capability. Again, depending on your workload type, right? So that if it's a compute intensive, definitely you need to worry, you get the best compute capacity out there. Then memory capabilities, network performance, storage performance, right? So the throughput is important. Then you really need to look into the network and storage. Memory capability, if you're doing a lot of in-memory tasks, you need to make sure that your instance type is suitable enough for your workload, and you decided that. And all these information, which one you should pick, is all detailed out there. So many instance types, it's very hard to capture in slides, and that would confuse you at this point, because we are talking about how SQL Server fits in onto AWS, and there will be other immersion days where we will deep dive in detail for people who come with SQL Server background, that how does it really work and what instance type to select and whatnot. I would bring one thing to your attention. If you or your company needs any sort of help, please feel free to reach out to us at NorthBay, and we are experts in this domain. We are, as I said, one of the premier partner out there, and we have extensive experience. Our team specializes in this, recommendations and assessments and doing the actual migration and things like that, right? So feel free to reach out even after the immersion day, and we would be more than happy to answer any questions you may have, any concerns you may have, or be an advisor to you. So in general, SQL Server workloads typically benefit from large amounts of memory. That's the way it is. That's the way SQL Server is architected, I guess. So consider DB-R4, it's a memory optimized instance. Additional licensing may impact DB instance class option, right? So it's a bit complicated. There are people who specialize in the licensing and pricing model for on-prem versus cloud, right? So I'm in no way expert in those areas. I go with the recommendations generally and try to seek help with the people who have expertise in this licensing and pricing model, because they do different, cost benefit analysis and whatnot, and then they come up with the recommendation. But in general, consider DB-R4 family, and it's a memory optimized instance. DB instance can be modified to change the DB instance class. So you can change the DB instance class to any other class, but it requires a reboot or failover in multi-AG environment. Can scale compute capacity with the workload if practical. Again, these things needs to be evaluated against your workload, against the data size, a lot of different factors, right? Data accessibility, data caching, and things like that. So these are these performance planning suggestions are very high level, right? So in general, this applies, but again, your workload needs to be assessed in order to make the wise call which instance to go for. DB instance can also be modified to change storage. It can modify to change the size, type, and PIOPS, that is provisioned input output per second. Okay, size modifications available within minutes. Yeah, so you can do these things within minutes, and some things can be done within seconds. I think that's a benefit of cloud. Storage performance degraded during optimization. Of course, if you are if doing some sort of optimization, the storage has to catch up. So there may be some performance degraded. Generally, it is not noticeable, but still there may be some. Okay, so EC2, I guess by now everyone is very clear that what EC2 can offer, right? So a lot of admin work is your responsibility. Lots of things the customer needs to manage and maintain. A lot of architectural decision relies with the customer. A lot of design decisions and any other security aspect again stays with the customer. AWS has a very minor role to play. Okay, so but in case of RDS, mostly things are managed for you. So that's the reason why we are talking RDS here. And trust me, if you go with RDS, in my experience, I have not seen any particular feature that is missing, except, okay, please note this carefully, except one when it comes to SQL Server BI features, right? There are a lot of gaps when we talk about things like SSIS and other things, where if you are heavy on those type of work, then you have to consider EC2. Okay, then in that case, RDS may not be a right choice. Okay, but otherwise, RDS has to offer everything you can think of, and it does the best job. And it's not just for SQL Server. I would say it does it for any database engine you migrate it to. But keep in mind the things which I highlighted, that still your schema design, your architecture, database architecture, those things, all those work still resides with you. You cannot just write a poor schema or data model and think that RDS will optimize it. That's not job of AWS, right? That's what you are doing. Same applies to application sites. All right. So people who are coming from database background, I'm pretty sure they all know, relational databases are complex. I won't agree because I consider relational databases as my first love. I started with Oracle 6 back in 1995 and spend a lot of time in databases, Sybase, DB2. So I don't find it complex, maybe just because the number of years I have spent on databases, but still, it is complex. It takes time to understand how the relational database works, how the things fit together, understanding the concept versus transactional database versus reporting database, understanding data warehouse. So there's a lot of different concepts. People who are coming from database background with 5+ years of experience, they must have realized that it takes time to get a grasp of it. But once you understand how it works, then I don't say it as a complex technology. I find it interesting, and I'm really fascinated with it till today. Okay, even though we talk about big data and all, but RDBMS is still very much in demand, and it's very much people are looking or depending on it. So our experience running Amazon.com taught us that relational databases are challenging to manage and operate with high availability, right? Yes, I agree. When it comes to unstructured data, sometimes you have to denormalize the data and stuff like that. In that case, may not be that every use case fits into RDBMS world, right? That's the reason we have big data or NoSQL databases so much in demand and widely used, right? So this is just because to reduce the complexity of what relational database has to offer, right? It's expensive and complex to manage administrative functions, including regular patching cycle, performance, backup and restore, disaster recovery, all for constantly changing applications, right? So there's a lot of dependency on databases or database skills or people with database expertise. Even for, in traditional days, the way software development used to work, like if you have to add say a field in a table or a column in a table, generally it would be the database administrator or database designer who will go ahead and see if it makes sense, which table to put in, and then it would, application developer will just make that request, and that request is generally fulfilled by DBA group or database group, and then the development would continue. These days, like if you're using big data, you don't really need to worry too much about schema and all. You can do pretty much whatever you feel like or whatever your application demands, right? Other challenging aspect, what it highlights here is that constantly changing application, which is good, as this is what I discussed. But at the same time, there are a lot of patches which are released very frequently by some of the companies. Performance has to be always kept an eye on. Backup and disaster recovery has to be pretty much tested throughout the year or throughout the changes, especially if you have made any, and make sure everything works the way it is, right? So a lot of admin work or maintenance work is involved when it comes to RDBMS, right? Keep in mind, this same applies, when it is SQL Server on EC2. Okay, so don't be that, okay, because RDBMS is complex. If you're not going with RDS, still you have to worry of performance optimization, patching cycles, and stuff like that, because AWS is not going to do that for you. Self-managing RDBMS is time-consuming, complex, and expensive. Hardware and software installation, configuration, patching, and backups. Everything is time-consuming, and a lot of, it's not just one DBA. And like if you're talking about bank or healthcare and insurance and all that, a lot of people are involved in database group, and they all have their own set of tasks and roles and responsibility to fulfill. Performance and high availability issues. You will keep running into these issues if you are managing it on your own, because everything that brings a change needs to be taken care of in these aspects. Capacity planning and scaling cluster for compute and storage. Again, scaling is still a big deal when it comes to on-prem database installations and management, because you really need to plan out, because every machine server costs thousands of dollars, and you don't want your manager to be upset just because you are buying machines and the servers end up being in a server room and not getting used, right? So a lot of capacity planning involved, heavy capacity planning, I would say, and scaling the clusters and stuff like that. You have to be pretty smart in database aspects to make sure that it works the way it should be. Security and compliance, agreed, because if you have worked for, say, mid-sized companies or large companies, there's a compliance and security department on its own, which ensures, generally they do audit and make sure that everything is secure and compliant. And it's very important when it comes to meeting the compliance, such as HLSEP, HIPAA compliant, and or any other financial domain related compliance. It's very important that we always are in compliance and all the security that is expected, not just from the database standpoint, but be it infrastructure or physical layout of the building or application programmer, the roles and responsibility or the access mechanism, everything has to be well taken care of, right? So, and you might have seen offices where you are not allowed to go in certain areas or certain rooms because they are server rooms or they're highly sensitive data in those areas. That's part of the security, right? So these are some of the things which are complex and expensive and time consuming, of course, because everything has to be done by you or your team. So these are the points which are sort of a overhead, considering the fact that we have cloud providers out there who support managed services as well. So managed relational database service with a choice of 6 popular database engines. So you got Aurora, you got MySQL, you got Postgres, MariaDB, SQL Server, and Oracle. These are the engines that are supported in RDS. Some of the key benefits: easy to administer, easily deploy and maintain hardware, OS, and DB software, built-in monitoring. That's one of the good things what you get. So you get the different levels of monitoring. We'll talk about that in later slides, but built-in monitoring is there. Secure and compliant data encryption at rest and in transit is provided to you. Industry compliance and assurance programs. So AWS have quite a extensive compliance and security documentation, and I can share the URL later on. And all those are documented and mention that what all they comply with, how the application and data are secured and whatnot. And whenever you get time, or do a bedtime reading, and you can get pretty interesting insight. How does it work when it comes to compliance and security? Availability and durable, automatic multi-AZ data replication. So it's all set up for you, automated backups, snapshots, failover. So, you can set up, snapshots, how often you want to take it and where you want to store it. Generally, people store it in S3. S3, if you are not aware, is a storage service provided by AWS. Then performant and scalable, scale compute and storage with a few clicks, minimal downtime for your application. So as I said, like we saw in the previous slide that you can change the instance type, instance, class and all that with few clicks, and it's a minimal downtime. And if you have architected it well enough that it has multi-AZ and all that, I don't see much of a downtime happening there, right? So that's another thing, because you can have different model of deployment. I'm not sure if you are aware of, things like blue-green deployment or canary deployment and stuff like that. So there are different mechanisms that can be approached or that can be followed while doing this. Any questions, guys? Yay, RDS, fully managed. It looks, sounds interesting, fully managed. Spend time innovating and building new apps, not managing infrastructure. See, again, they are emphasizing on building new apps, right? So architecting the new apps properly, making sure you're using the right design patterns and stuff like that is still important. And you don't need to worry about infrastructure. That's, I guess, applicable to any service when we go to the cloud, right? Because infrastructure is pretty much managed for us. And when it comes to RDS specifically, it's specifically talking about database-related infrastructure, right? So what you are worried about is schema design, query construction, query optimization, right? So still, your expertise in database is very much required, right? So schema design, how do you design the schema is very important. Even one other thing on the other note I would add here is deciding whether we want to use relational database if we are really migrating. Another option can be you just want to go to big data. On the other note, nothing to do with this session, okay? I'm just throwing an idea. So that should be the first step, in fact, to whether to think that, if their database makes sense to go to big data kind of environment or NoSQL or any other option, right? But if you're going RDS, that schema design is still you, query construction is still you, query optimization is still you. I have one of the project where there are, existing code written by some third party, and we are running into all sort of issues with the query itself that has been written. And even though it is running on AWS, all sort of crazy performance related issues are showing up, right? So we had to involve a database expert and get the queries optimized, and then it's working the way it should be, right? So very much your responsibility, okay? And generally, I have not seen in recent years that app developer would have all these skills, so still you need people who have database background so that they can write the best queries, use explain plan, and do all sort of indexing and implement all sort of mechanism to make sure your database is optimized, right? So those things still is very much in your responsibility. What AWS does for you: automatic failover. It does the backup recovery for you, isolation and security, industry compliance. AWS is very heavy on compliance. So, it's interesting that that it's doing so well in that area. Push button scaling, right? So you can add servers, you can delete servers, how many servers you want, and things like that. Just a click away. Very user-friendly dashboard or console AWS has, so it's pretty easy to use, and you will see it in the lab that it's fun. Automated page patching and upgrades, advanced monitoring, routine maintenance. We'll talk about monitoring later, but advanced monitoring, because it has a lot of tools which generally are not part of the database itself. So we used to end up buying it from some third party, but AWS has quite interesting monitoring tool that is inbuilt in AWS RDS as a service. Basically, it's available as option for you. All right, Amazon RDS for SQL Server. On the right side, the boxes you see here, again, it's just AWS keeps highlighting that we will do everything for you. It's the same SQL Server DB engine as customers run on premises, so your engine is not really changing. Management, monitoring, and automation layer around the DB engine. Automated full DB instance backup with point-in-time restore. So there's point-in-time restore already available for you. Automated high availability, because it deploys into multi-AZ and multi-region deployment if you want. Automated provisioning, patching, monitoring, directory integration, right? So you will see in the lab that by the few clicks you will be able to bring up a database instance up and running, which anybody can use, right? So otherwise, generally it used to take quite a bit of time to set up a database and installation and setting up all the aspects and access and everything to it, right? So that's there. So that's some of the benefits highlighted again for RDS. All right. So what are the different options? How do we deploy and manage RDS for SQL Server? There are multiple ways. So pretty much all the options that AWS offers for any other service are listed here. And SQL Server is no different. So Amazon RDS Management Console, which you will use during the lab. Then you have command line interface, or you can use PowerShell. You have AWS SDKs. So if you are good programmer and want to make use of SDK, please feel free to do that. And then, of course, you have CloudFormation templates. So I don't know if you are coming from, if you have any experience in infrastructure as code. CloudFormation is one of the services that AWS provides. Other similar services are like Terraform and all. So if you're familiar with any of these, you can use pretty much to deploy and manage your RDS for SQL Server there. Okay. I see one question is still pending. If one of the panelists can answer that, I would appreciate it. All right, securing SQL Server. This is a diagram which, if you are familiar with AWS, you will see it everywhere. Pretty much any service you try to evaluate or anywhere you try to go, you will see this, because it clearly talks about what you are responsible for and what AWS is responsible for. So this is referred as a shared responsibility model. So customer data is your responsibility. Platform application, IAM, that is identity and access management, is your responsibility. That is whatever is in the cloud, right? So operating system, network and firewall, client-side data encryption, data integrity, authentication, server-side encryption, network traffic protection, and all that. What AWS does for you is software, compute, storage, database, networking. So these are offered as a service. So it has concepts of regions and availability zones. Then you have concepts of edge location. So that's what AWS. So if you really want to understand it, whatever is in the cloud is customer's responsibility, and whatever is off the cloud is AWS responsibility. Okay, and that's referred as a shared responsibility model. All right. Securing Amazon for RDS for SQL Server, some of the key controls which we need to worry about. So network topology. So if it's a VPC you are setting up, you need to control the subnets, AZ specificity, that is, which route tables, NACLs. If you are not a network person, you may seek help from one, because if you configure these things incorrectly, you might be introducing some security gaps there, right? So use things like security groups. So generally what I have seen when people are migrating, our database to, or SQL Server database to RDS, they would involve someone who knows AWS networking or AWS security, and seek their help in these layers, if you want to call it. Okay. So public access, avoid it or limit it. I would say generally database should not be exposed to public, but I don't know, people may be doing in crazy things and they want to expose all the data they have, but generally it doesn't happen. So, make sure that you keep it in private subnet. Encryption, force SSL supported. Different options are given to you. As I said, key management services provided, TDs provided, column level, encrypt before saving, a lot of different options. Resource control, use IAM, right? So that's a domain in itself. It's a service which is applicable pretty much to everything what AWS has to offer, right? So make use of IAM roles and users to control the resources. Data access, native SQL Server capabilities is supported. And then, as I said before, SQL and Windows authentication are the two mechanisms that you can use to provide the access to the database itself. For the audit, AWS has another service called CloudTrail to log AWS API invocation. So whatever, if you are using, RDS related APIs and you're making call and doing things with API, CloudTrail will log it, right? So you have to enable it, and it will log all the API invocation for RDS service. Use SQL Server Audit to audit database and server operations, right? Which is good, but this doesn't mean that the way we used to do in our older days, that some sort of auditing mechanism at the database level itself about data, who changed what, right? So that those sort of auditing is not captured here. That still you are responsible for that, right? So if somebody has changed some sensitive data, you want to track it down, when it was changed, why it was changed, and how it was changed, and who changed it, and all those kind of fancy stuff still needs to be taken care of, right? So that is something, if it's specific to your business, you are still responsible, and there's no other mechanism of doing it. Ensures only authorized user can connect to the database. So SQL Server Authentication, Windows Authentication, you can use any of these. These are the two mechanisms supported at this time. All right, so we talked about this and why we need audit. I think pretty much all of us are familiar that it increases accountability, anomaly detection, track usage, satisfy compliance record events to binary files. One of the key aspects I would like to highlight here is the compliance requirement, right? Because every, depending on the business, I would say, but generally, most of the businesses have to comply with one or another regulation out there, right? It may be, privacy law. It can be any compliance requirement which the government has binded them as a business. So they need to maintain the audit, maintain the changes that has been done, be it data, be it infrastructure, be it any sort of configuration, right? So in case of SQL Server, it's all stored in S3, and generally it records the event in binary files, so it's hard to play with, and it's all readily available for audit purposes. So there are different options. I won't go in detail for SQL Server Audit, but how it is done, it's enabled by our options group. Once you are having a good handle on SQL Server on AWS using RDS, you can see these options, and you can see what you can do with. Stored in your S3 bucket, you can specify the bucket name, options, server-side file compression. If you want to compress your file, configurable retention, how long you want to keep the audit files for. It may be some company may have 180 days, it may be 365 days, whatever, but it is all configurable for you, right? So that's what you can do with SQL Server Audit. All right, so for performance monitoring, these are the tools that are offered to you as part of AWS RDS. So CloudWatch metrics, it monitors core CPU, memory, disk metrics. If you talk about CloudWatch logs, publish SQL Server agent logs and error logs to CloudWatch, you can configure that. Performance Insight is my favorite tool because simply reason being, when it comes to optimization, this is the tool you go for, right? It will tell you the queries that are being bottlenecked. It's going to give you all sort of metrics that you need to make sure that from design and architecture and the coding standpoint, you have done the best possible things, because it will highlight all the areas or all the queries that are becoming the bottleneck for your application. It may be related to anything, but it gives you a good insight, and we'll see it later, but how the dashboard looks like. So it's all offered for RDS only. It's not available outside, like generally for EC2. If you go for SQL Server native tools, you can use DMVs and Profiler. So these are tools which are native to SQL Server. Third-party tools these are just lists. There are a lot of them. So you can go to, again, AWS Marketplace and evaluate the tools that make sense for you, and see, what kind of metrics you're looking for. But generally, if you go with CloudWatch logs, and and the performance insights, it gives you pretty interesting insights. But if you're really looking for something which are not offered by tool, feel free to use either SQL Server native tools, or you can go for what you call Marketplace and evaluate. Or if not Marketplace, then whatever is your preference. All right. All right. So this is a dashboard for CloudWatch metrics. So you can think, number of DB connections, CPU utilization, free storage space, how much memory can be freed up, write, read IOPS, queue depth, read, write throughput, swap usage. So things which are specific to databases, CloudWatch metrics would provide all that information for you, and nice layout, as you can see on your right hand side, right? So generally in traditional days, we used to write commands for all this, and you have to memorize all the commands. But now you have this nice dashboard offered by AWS, where you can get all these insights by just clicking on a link, right? So this is quite useful. There's something called as enhanced monitoring, which you have to enable when you're using AWS RDS. So if you enable enhanced monitoring, it gives you OS level monitoring metrics, 26 system and per process metrics. It gives metrics delivered to CloudWatch logs up to 1 second of granularity. So pretty interesting. So if you want to enable it, go ahead and enable it if you're really looking at OS level data. I know that the screenshot might not be very visible, but you can, once you log in, you can view it in your console. Compared to CloudWatch metrics, agent-based metrics collections, there can be difference with CloudWatch due to collection source, right? Because they both are two different features, right? So their data may be not exactly the match, but pretty close. Based on my experience, the data generally enhanced monitoring gives you, it's much more detailed because it covers OS level as well. But the metrics which are given by CloudWatch is equally trustworthy, right? So you can go with either. So you really want to deep dive into what's happening at OS level, enable enhanced monitoring. Okay. Performance insights, right? Nice dashboard, easy and powerful dashboard showing load on your database, average active session, helps you identify source of bottleneck, top SQL queries, weight statistics, right? So even if you have written poor queries, it will show here that your query is taking 5 minutes to execute. 7 days of performance data history free, perfect for developers, up to 2 years of long-term retention for production use cases, right? So 7 days of history is maintained, but after that, you need to evaluate what their pricing structure looks like, and if it really helps you. I think it for people who are just doing a lift and shift, it might be useful initially to make sure that everything is performing well as far as the queries are concerned. So it's a nice little dashboard, shows a lot of insights. So generally what I've seen is not one tool will solve the purpose, right? So again, as a database expert, you would need all these tools enabled and make sure that you can understand what these metrics are and work, plan your next steps accordingly. All right. So performance planning, we talked about one instance DBR4, but you can also consider from, generally memory, large amount of memory is recommended for SQL Server workloads. So consider DBR5, DBX1, X1E. These are all memory optimized instances, right? So they are heavy on memory and it's structured or architected in a way that the memory is already optimized. Addition and licensing may impact DB instance class option. Again, not all instances are available for given addition or given licenses. So you really need to go through and see what you currently got and how does it, which instance it fits in, which instance family it fits in. DB instance can be modified to change the DB instance class. We talked about that. Use DB parameter groups to adjust DB instance configuration, right? So DB parameter groups are a set of database parameters that a given instance should pick up automatically when you are spinning up an instance, right? So you can create parameter groups and DB instance can read that and implement or make it a kind of you can think of it as a template that you want for every DB instance. Amazon RDS storage throughput depends on DB instance class, right? So you might be thinking that we talked about is highly available, it's a scalable, auto scalable. So many things are already happening. So why we need to worry about? But again, these are the areas, or these are the reasons, I would say rather, AWS experts are needed, right? For any sort of migration or, if it's a greenfield project, because you need to have a good understanding, even for things like as simple as choosing the right instance type, right? So you need to get hands on different aspects of AWS before you actually migrate your SQL Server workload, right? So these are some of the things which you need to worry about, or at least get internal or external help in order to get this resolved. Know your workload, but there are different instance types. So bustable instance types is one. Basically, in a layman term, it's an instance type which can burst to a particular extent in order to support your short-term spikes. Then you have scale up and scale down. You can configure this, that how many systems you want to scale up, what should be the minimum number of servers and things like that. And then there is option called reserved instance. So if you have workloads which are going to be running for next 2 years or 3 years, so you can look into things like a reserved instance. Reserved instance is nothing but sort of a commitment to AWS where you get huge discount on these pricings or the cost of the instances, right? So there are generally 1 year, 3 year term, and they have options like zero down and partial down and full upfront and all that. And you can look into the pricing of those, and it really saves you a lot of money. Generally it ranges from like 50% and up, right? So if you have instances which are going to be running for months or years, you can look into reserved instance. And they have started making this more flexible, where you have option of something called as convertible instances, right? Where you can even change instance family during your commitment, which is a very good thing. Before, it used to be once you have taken one family, you have to stick to it. Now, if the things change, you can switch between the instance family, and that makes it more interesting. Bustable instance types generally is used for dev tests, smaller production database, baseline CPU performance, burst performance with CPU credit. So you have CPU credit, as I said, and it can basically spike to a certain extent, and after that it won't, right? So that's the reason it's called bustable instance type. Scale up and scale down, right? So depending on if it is holiday season and you are in retail industry and people shop a lot, during that time you may want to scale up. And generally, say in January, people have run out of their cash after all the shopping. You can scale down, right? So this bottom line is you have this option that you can, for periodic workloads, you can scale up and scale down as you need, and this is all configurable. As I said, reserved instance, steady state workloads, 1 and 3 year terms, no upfront, partial upfront, or all upfront, savings up to 61%, right? So that's what it says. But if you look into convertible RIs and stuff like that, and partial upfront, then this number can change. But this is on average the saving you're looking at. All right, so I think we are right on time, probably 3 minutes late because we took 3 minutes for our introduction. And I hope you guys got some good insights from this session. And let me share some information about the lab. Okay. All right. So
while Raj is opening up the lab session, I wanted to give some guidelines on the lab, how it's going to work. So we will be using one of the event engines where you'll be automatically provisioned an AWS account. And there are some instructions. We'll be going through some specific sessions about the workshop. And as I mentioned earlier, usually these type of immersion days run for the entire day or multiple days. So we have picked and choose that fits into this virtual immersion day sessions. So we have selected some of the topics that mostly align with the conversation that we are having. And as we have been mentioning, please feel free to ask any questions, leverage this time for any questions that you have, both around the labs that you're going to do, and also any other questions that you may have during the conversations that we are bringing in. We are doing our best to answer your questions regarding the Q&A, but we can also entertain some of the questions during the labs.
yeah.
Go ahead.
Yeah, no, thanks, Lakshmi. That's a great insight. Sorry, I missed on that. So everyone, I'm sharing a link. Let me know if everybody got it. It's rdsms.workshop.aws. I would request you all to click at this link at this time. I hope everybody is able to get to the site. If anyone has an issue, please write in QA or chat, whatever works for you. So what we are going to focus on today is on the left-hand side, you see a menu bar with all the options. So you will do option number 1 and 2, that is create new RDS SQL Server instance. That should not take more than 25 minutes. And then the second would be highly availability, that is 40 minutes. Generally, it is done. The timeline is pretty good because we have done this so many times that within the time frame given here, people are able to finish. The next information I would like to share is the agenda for this lab is listed here. So whatever you see on that menu bar on the left side, that's what it is. And the event engine where you will be performing this lab. I'm going to share this right now. Okay, that. Okay, let me share my screen. Okay, let me just share my screen because that would make life easier for everyone.
So a quick note to some of our internal team members from the North Bay side. So uh, let's not start the event engine. So we do have a separate process for internal North Bay team members. So do not go through this event engine. Just a quick note. Thank you.
All right. So I have in the chat box, thanks, Lakshmi. I have shared a link in the chat box. So please go to this link and you will see a page like this. Once you are there, click on email one-time password, or in your case, it may be asking you for a code, a temporary code. In that case, please use this code which I'm sharing in chat. It's common for everyone, right? So you may be getting a difference. I already logged in before this session, so that's the reason it's not asking me. But instead of this screen, you may be getting a screen where it is saying enter your code or something. So use this code which you have, just copy paste, and then it would bring you to this screen. If you can raise your hand, if you're able to get to this screen, that would be nice. Perfect. Very good. Fantastic, guys. Okay. So then don't click on any other option. Just click on the very first one, email one-time password. In this, type in your email ID and click on password. Once you have done this, you will receive an email ID with let me stop share for a second. But once you have that passcode, go to your email. You should receive an email from it would say AWS training. Once you have that code, paste it here and click sign in. Raise your hand if you are able to see team dashboard. Okay. On the very top, you're not seeing here, but I'm not seeing here, but you will see it on your screen. There should be something team name. Click on that and enter your name there. Does everybody see a, raise your hand if you see a button saying team name. Wow, I love this. People are so fast and moving so quick. All right, perfect. Click on that and put in your name, please. Once you have done that, you should see this page, what I am seeing on the screen. If you see the same page, please raise your hand. Perfect. Click on SSH key. and click on download key. You may not be required to use it, but just in case. All good? Please raise your hand if you have downloaded the key. Everyone, I want to see some more hands raised so that I know. If you're stuck, guys, please ping us, okay? All right. So we have 3. I will wait 5 at least. 3 are done. So 2 more. Raise your hands if you are on this screen. 4, 5. Perfect. All right. So now you're good to go. You can click on AWS console and click on open AWS console, which should take you to this screen. Raise your hand if you are seeing this screen now. Everyone is good? Okay. Now in here, just search for RDS and click RDS. There you go. So welcome to the world of AWS RDS. I wish you guys all the very best for your lab, and we are here to help. Please feel free to ping us anytime, ask any questions, and follow the steps exactly as listed in here, and you won't be stuck. Please make sure you don't skip a step, okay? Because this is all configured for your lab exercise, the account what you are using. So if you miss a step, it will be very hard to troubleshoot, because we have kept it in a sequence that you should be able to successfully go through the steps required to complete the labs, right? So please do as the steps are identified, and don't miss any. So I will stop sharing my screen, guys, and all the very best, and we are here to help. Thank you. Thank you, everyone, for your time today. Thanks to all the panelists as well for supporting me during the QA session. So I appreciate that.
Thank you, Raj. And as Raj was mentioning, so please continue. And if you have any questions from the session itself, or do you, or any experiences, or wherever you are with your journey to cloud, we are here to help.
Hi, excuse me.
Yep. Go ahead.
I'm Daniel Salumbre. I downloaded the SSH key, right?
Yep.
There's an SSH key, team dashboard, SSH key. I downloaded that. So what do I do next?
You can go back to an earlier screen and open the console.
Oh, okay.
If you're not seeing the OK button, it's just the way the layout is. So if you scroll your bar a bit low, you will see the OK button. So click on OK, or otherwise do a back, and then there will be an option of open AWS console. So just click on that.
So there's yeah, basically it says there AWS console login.
Yeah.
And then just say OK.
Yeah.
Okay, I'm back to the team dashboard screen.
AWS dashboard, right?
No, actually, I don't go there.
What do you see on screen?
Right. Can you go
see
back?
the team dashboard. The team dashboard event North Bay RDS Immersion Day.
Let me share my screen and tell me if you see this screen.
Sure.
Do you see this screen?
Yes, I am in. Yeah, I have set team name. So I get
click on that.
Set team name.
Yeah.
Okay.
Type in your name.
Okay.
Click OK. Let me know when you're done that step.
Okay, so there it is. Okay,
Sorry?
then I got that.
Okay. So now do you see this AWS console?
Yes, I do.
Click on that.
Yep. Yep.
And then you see open AWS console.
Okay.
When you click on that, it will take you to the dashboard.
Yeah. Yes, I do that.
Do you see the screen what I see?
Yes.
Okay. Here type in RDS.
RDS, right?
RDS, yes.
On the top, right?
Yeah, on the search bar, type RDS.
Yep.
Click on RDS.
Yep. Okay. There you go. Hold on. There you go.
Yeah, and now you go back to this and start doing your
Oh, okay.
steps.
Okay. Thank you.
No worries.
Okay.
Anybody else having issues?
Hi there. Just a question.
Yeah.
I'm at the step where you're supposed to pick virtual private cloud, and I do not see the same VPC, the one that is mentioned in the instructions.
Okay.
So am I supposed to create a new VPC with the same name?
Yeah, you can create one. That should not be a problem.
Okay, sounds good. Thank you.
Yeah, thank you. But please make a note of it, because if it asks for somewhere else, use the same VPC.
So are you using the default VPC? That's already there. It may be a different name, but as long as it's whatever is mentioned in the instruction. And these labs will be available for the next few hours, I think for another 6-7 hours, even after the session is closed. So you will have time to practice if you're not able to complete within the immersion time until 5 o'clock. And if you are able to finish the sections apart from what we have mentioned in the agenda, you're also feel free to do more as a bonus to actually go through the entire workshop so that you're aware.
One more thing, guys. If you are using anywhere like a specific name or some values which you are specifying different than what is in the what you call steps, make note of it, because even the part 2 of the lab after the second presentation, it will be a continuation of this, right? So just wanted you guys to be aware. Don't do things like fire and forget kind of thing. So make sure that if you are doing something which you are defining on your own, make a note of it. Thank you.
How long does it take for the database to create? It's been sitting in like creating state since last few minutes.
It does take some time, so no worries there.
Okay.
Yeah, I think it takes anywhere between 5 to 15 minutes. So what happens is it provisions the underlying storage, and once it starts up, it also takes a backup for the first time. So you would see some messages coming on it's getting started, taking the initial backup, and that's when it's available for you to use.
Okay, thank you.
So while the team is waiting, I wanted to share some more thoughts, right, on the creation of databases. And again, beyond the lab session, I want to walk through some of the things to be known and what are the best practices and so forth. So I'm pretty sure that the team has gone through. As you can see, the standard create, easy create, it may not have as many options. As you can see, I think Raj was mentioning about multiple options around managed databases. So the one that we are doing for today is Microsoft SQL Server. There are multiple options within SQL Server. There is an Express Edition, Web Edition, Standard, and Enterprise. Depending on how you are utilizing within your company, select the appropriate ones. So we have seen some customers where they have a combination of, they do have some components with Enterprise Edition, some with the Standard and Web. Again, it all depends on your licensing terms that you have and what options within these data stores that you're using. So pick the appropriate one when you're actually working in your own environment. For today's lab, we will be selecting the SQL Server Enterprise Edition. And depending on what you select, it automatically pops up the different versions. So as you can see, it supports anywhere from SQL Server 2012 to 2014, 2017, 2019. So one thing to note, as Raj was mentioning earlier, right, how do you know when you're migrating to cloud? Uh, RDS is a better fit than SQL, so than running it on EC2, running it on a virtual machine. I think that the best way to think about it is start with RDS first approach, look for the limitations. Limitations being, does it have the version that you're looking for? Your on-premises may be incompatible. It may be too old. Would you be able to upgrade before you migrate to RDS? Or would be, if it's compatible, then start with this. So for any, there are additional set of limitations. So I'll share the link, but it has the things that will work and will not work on RDS. As long as everything is working, go with RDS because it gives a lesser overhead. And the other templates that you can see, the production and dev test, primarily what it picks when you select production is it automatically configures the high availability. It automatically configures some of the retention policy. It automatically picks some of the database parameters that you would need for a production grade environment. It picks the right option groups and so forth. So instead of selecting each and everything, the production automatically configures. So for when you're actually doing it in your environment, select it appropriately. If you're on to run on a single availability zone, if you want high availability features and the performance and so forth, there are some defaults that are set using the templates that you pick. So moving on, I think these would be the standard ones, the database identifiers and credentials that you will be using. So one thing to highlight here is because this is managed by AWS, you would not have what you call the super admin or the system DBA, right? When you're doing it, you would get probably 90-95% as a on-premises SQL Server admin. There are some things that are not possible. Again, this is also an area where you see if your custom application, it's reliant on this super admin to do any of these tasks. It's one thing to consider whether all your application when you're migrating to AWS is compatible or not. The moving on to the selecting the right instance size, this is going to be key for your performance and scalability and your overall cost. So depending on the ones that you select, as Raj was mentioning in his session, the M class, there are different types of instances. There are instance classes. Within each, there are small, medium, large. You can think of like a different sizes. It has the information of how many number of CPUs you have and how much RAM it has and the overall network capacity, the IO that it can support. So depending on what your workload type is, so I would say based on our experience, the for non-production, especially sandbox and dev and test, maybe burstables are better because again, it's probably much cheaper. And what happens with the burstable ones is you wouldn't it supports for high performance in bursts. So as long as you're not needing your workloads, doesn't need a consistent IO, consistent CPU and memory, as long as your workloads are spiky. So that's when I would use the T3 type of instances. For the production workloads, always recommend the MRR classes. For high, if you're using these enterprise applications like SAPs and other Microsoft Dynamics, where it's a heavy ERP usage. So in those cases, I would consider the R and X classes, probably going to the higher capacity. So the bigger ones that it can support is up to 48 CPUs and 384 gig of RAM. And this is also an area where you consider whether to use EC2 or RDS. EC2 have many more instance types that are beyond what you can see here. If your requirements are much bigger than what RDS can offer, what some customers do is are you also taking this opportunity to split your big monolith application? It's very common that customers run multiple databases, multiple applications on a single database server. This is also an opportunity to isolate a database per application. So depending on whatever your needs are, these are the available options. So one thing I want to highlight is that on the storage. So the key advantage that you would get with again going from the traditional legacy type of hardware is isolating between compute and storage. So what you just saw is the compute. Compute only involves the CPUs and memory and the network throughput. And the storage, you have multiple options. So if you want a consistent I/O versus again the general purpose is kind of because it's a shared infrastructure. Sometimes you see it's performing better, and sometimes you may or may not see, depending on what the other tenants are doing within the same underlying hardware. So you see that level of inconsistency. So what we recommend here is, at least for your production capacity, production SQL servers, we recommend using provisioned IOPS, and the general purpose and magnetic are cheaper. So we would recommend using for your non-production. And depending on the storage engine, there is a maximum capacity. So as you can see, it supports up to 16 terabytes of storage for SQL Server, and how much IO per second that you're looking for. The IO per second is a multiplier of the amount of allocated storage. So if your workload is uneven, you only have 10 terabytes of storage, but you want 30 or 40 IO per second, 40 GB, 40,000 IO per second, it may be inconsistent, and that's the reason you may have to sometimes over provision, under provision the combination of CPUs and memories and IO. It may not be a direct to match in some cases, but pick the relevant option. As you can see, there are some newer options, like automatically, if you want to increase, as you keep on adding more data, it can support auto scaling of the storage. And the other key feature where a lot of customers are inclined to go to SQL Server RDS is because of this high availability option. Because I was a DBA myself, but there's a lot of effort that goes into operationalizing the high availability architectures. Is the replication working? Is the mirroring working? How do we test if it's working or not? What happens? How do we connect the applications to databases if something in a scenario of failover or disaster recovery? So all those things, it is handled by AWS. And going back to the VPC question that we had earlier, VPC is a logical construct to isolate your resources to be more secure. So usually the common recommended practice is you will have a private subnets and public subnets. Never ever put your databases into public subnet. So again, pick the relevant. Again, this is where you would work with your networking team, infosec team, to basically lay out how many VPCs do you need, how many subnets do you need, and you select that information, whatever the shared services team provide. Again, highly recommend not to allow public access. Security groups is kind of a network firewalls. So you can only allow a specific IP address range, specific ports. Again, always recommend that you only open up the ports and only open up from the subnets or machines that needs interaction. That's what you would do. Moving on further, the SQL Server Windows authentication. Yeah.
Sorry, can you click on the additional configuration arrow, right? Daniel asked this question from where he can change the port. So the additional configuration, just scroll down a little. No. The additional configuration section, we're under the VPC section. Additional configuration option under the VPC section. Yeah, there, right on the screen, under default, at the bottom of the screen. Yes. Daniel, from here, you can change the port. This is the option from where you can change the port. Thank you, Lakshmi. Sorry for interruption.
And so one of the question is how do we integrate RDS with Active Directory? This is a very common question for a lot of enterprise customers because again it's rarely that especially for SQL Server you do not maintain the local users, so it can integrate with your Active Directory. There are multiple options. I think we have responded to one of the questions in the Q&A, where it can integrate with your on-premises AD, your AD from anywhere else. AWS also has this AD connector or managed Active Directory. You can integrate with any of those. And this is the key. But again, for labs, we may not be going into much detail, but there are some labs on how to change the option groups and so forth. So this is where you basically keep a trail of whatever changes that you're making to database parameters and options, and you select the appropriate option. So the parameters, how much memory you want to allocate, how many process you want to allocate, whatever the standard options that you have, you can select those. And as one of the key features of RDS is also automatic handling of the databases backups. So you can enable automatic backups. There is a maximum retention time of 35 days. Again, this is for the automatic one, but you can always create a custom backup where you can keep it as long as you want. You need to delete them manually or some process in place so that you can delete it. But automatic backups can be enabled up to a period of 35 days. And you can also enable encryption. Again, as far as security is concerned, I think it's one of the best ways to put about is the CEO of Capital One, which is one of the marquee customer of AWS. They said even as a bank, we could never be as secure as AWS is, because AWS has tens or hundreds of specialized the global security experts. Where security is thought out ground up. So for each and every service that you have, encryption at rest, encryption in transit, the higher level of encryption, the 248 key encryption, AES encryption, TLS 1.2 encryption. So all the latest and greatest algorithms and protocols and technologies that they're all integrated into majority of or almost all of the services, including SQL Server. So if you look at options around security, how you can encrypt, the key service here is what is called a key management service. It can integrate, you can use the customer managed key. There are multiple options: Amazon managed key, customer managed key, and bring your own key. If you already have a key store somewhere else, be it on premises or different cloud provider. You can export and import to KMS, and then you can perform the encryption at rest. It supports the TDE, transparent data encryption, on when you spin it up. It also gives the estimated cost. Again, this is when it comes to costing on AWS. So I think Raj also mentioned about different options. You can definitely get a handle or hold of these costs by going towards reserved instances and do you need so there are different ways to think about it. Do you need your non-production up all the time? Do you need it over the weekends or after hours? So there are many more options where you can dramatically reduce the overall spend. What we have seen is if you just go like to like, you have 20 machines and this is the CPU cost and this is how it's running on premises. If you do a like to like, maybe your bill may be higher, but if you optimize it for cloud, we have seen customers reduce by almost 60-70%, putting the right constructs in place. Any questions?
Lakshmi, there is one question regarding reserved instances. The lady is saying that she's not seeing the option of reserved instances on this page.
That's a good question. So reserved instances is a billing construct. So what you would be is whenever you're running any service, so reserved instances are there for RDS and EC2 and different services like Redshift and all these things, right? When you're running it, it's no different than running as on-demand and reserved instances, these are the type of instances. From the running a service or resource perspective, there is no difference. So what you would do is you would go and buy for reserved instances. So what happens is when you identify that I want to have 5 nodes of, let's say, M class with M5 large. So this is your capacity that you are planning to keep it running. So what you would do is you would purchase those reserved instances. And during the end of the month, whenever your billing cycle happens, it checks for how many, what is the size or capacity of your RDSs that you're running. Let's say you're running six M5 large in this example, and you have purchased for 5 M5 large. So what you would do is at the end of the month, it will deduct and adjust the overall billing, saying you already purchased for the reserved instances for this one additional one that you have created. You would pay for on-demand pricing. This is your overall bill. So you wouldn't see it as an option when you're creating any of these resources. It's just a billing construct which will adjust the overall billing when it's calculating the how much it cost. So any other questions?
One question is, are they going to get the copy of this webinar?
Okay. Yeah, I think we will respond to you. We'll publish it. I think once the webinar is over, we do have a process to share additional information. So I also want to announce, right? So we do have many more sessions coming up, and what we typically do is if your specific company has a need or looking further into it, we can also do at customer sessions. So what it means is instead of having attendees from different companies, which is the case right now, we can focus, have a conversation with your company to understand what you're looking for, so that we can customize this particular session to fit your needs. So depending on where you are, feel free to reach out to us after the session. If there is a specific need that you have where you plan to migrate your SQL Server workloads to cloud, we can help guide in any shape or form. So one thing I also want to highlight is when you spin up this database, you also have this VPC endpoint. The RDS endpoint. So think of it as it's an endpoint which can automatically transition to whatever the primary instance or node is going to be. So you don't need to worry about any of the load balancer, DNS switches, any of those. That's automatically handled. So let me know if you have any issues, concerns on the first lab. I think I'm assuming that some of the team members have already gone to the second one, which is the high availability. So a quick note on high availability. AWS has this concept of regions and availability zones. So each availability zone, I think that the easiest way to think about is it's a data center, a group of data centers located closely together. And whenever you're having any application, you're architecting, whether it's a database, whether it's an application, a web server, anything, it's very important to architect for resiliency. So you have to assume that anything can go down anytime. I think that's the quote from the CTO of AWS, right? Whenever you're having architecting, make sure that you're able to architect in multiple availability zones. So this particular session around a high availability, this particular lab will introduce you to what is multi-A availability zone, how it's going to work, and what happens when one availability zone goes down. Even though availability zone going down is an extremely rare case, taking the entire region out is even extremely rare case. So a lot of customers, depending on their high availability requirements, disaster recovery requirements, one of the common guidance or practice is a lot of customers are comfortable with a single region being a disaster recovery site. Some customers, they wanted to have the database or whatever their application running on a different region too. So for the scope of today's conversation, a single region application is good enough, and the availability zone, usually they are anywhere between 50 to 100 miles apart, and again, they are in a different power zone, different earthquake zone, different flood zone. So any one natural disaster or potentially any human disaster will not take away the entire region. So everything is totally isolated, and that's how you should think about architecting your solution.
So everyone, I have in the chat, I have shared a link to a detailed pricing plan for AWS RDS, just in case if you need, you can bookmark it. It would be helpful down the line.
So we do have again the next session coming up in 5-10 minutes. So if the team wants to take a break, so we can continue with the conversation. Again, we'll be here for any questions. If you got stuck in any of these two labs, feel free to ask. So meanwhile, let me take a poll just to get some understanding of the team members and what exactly your overall cloud strategy is. So I'm going to launch a poll. I'll give a minute or two to see if you can respond. The first question is around what is your personal experience with the public cloud. So again, there are definitely some differences across the cloud providers, but if anybody has experience working in any cloud provider, including AWS, Azure, GCP, or anyone, I think they're all relatable. Similar services do exist. There are definitely some differentiators, but wanted to understand. The second question is primarily around the cloud strategy for your company. A lot of enterprises, either they have, I'm pretty sure almost everybody is thinking about going to cloud. Somebody already made the move, and some companies wanted to keep some applications on premises for whatever reason, for the compliance reasons or the overall TCO, because some of them are sunk costs, and some customers are also looking into multiple cloud providers. So I think this gives us a better idea of where you are and how we can help with your journey. All right, thank you for responding quickly. So what I see is just in terms of the results, the experience with public cloud is mixed. I think more than 60-70% of the folks are either no experience or less than 2 years. And a lot of participants mentioned that they're looking for all in AWS solution, about 60-70%. And the rest of for 20-30% are looking for either hybrid cloud or multi-cloud options. So just sharing some of the customer experiences. So customers who wanted to migrate to cloud, it's usually a multi-phase or multi-step approach. We have seen some customers, they wanted to go to cloud as quickly as possible. And we have seen some customers running it the right way in cloud. So sometimes it can be the same thing, or it's a multi-step process. So if you have the software like the SQL servers and oracles, so there are ways to quickly migrate these solutions into cloud running. So coming back to optimizing, is it the best way to run it on cloud? There may be better ways. For example, migrating to open source like the Aurora Postgres or MySQL. So that's something that we understand that a lot of stakeholders, decision makers are willing to consider. by moving away from these proprietary solutions. In some cases, depending on the application that you're using, it may not be possible. Yeah, it's kind of mixed, but think of it as a multi-step process. Move as quickly as possible is also termed as lift and shift. Get it up and running on AWS as quickly as possible, and make any small changes like moving into RDS, and then re-platforming or moving from the SQL Server type of solutions to Aurora. These are called the re-platforming solutions. And then the re-architecting. If, as earlier Raj was mentioning, does the workload, does it mold itself into using the newer data stores like the NoSQL data stores or the cloud data warehouses? So depending on where you fit in, historically, a lot of customers have been using these relational stores as all in one store. So for anything and every use case or workload, they have been using these relational stores. Now we have so many options. It's time to think about, is this the right data store for the application that you're looking for? Okay, I think we are over at 3. So wanted to share my screen. Let me know if you're able. So again, in the second session, I wanted to focus on, now we have seen what an RDS is, how it works, and you have also seen some options of you can run SQL Server on EC2, which is primarily like a virtual machine. You can basically install your own software, configure it the way you want, the way you have been used to on premises. So there are primarily 2 options. How do you run SQL Server on AWS? Either you run it on an EC2 instance where you are doing the lot of day-to-day work, keeping it up and running, but doing the patching, doing the backups, maintaining high availability and all that. Or you can utilize RDS, which is a managed service on SQL Server. So when you're migrating, what are the different ways to migrate? What are the options? What is the best possible option that will work for your specific use case? So we'll be talking about some of the details. What are the options? And we will also end up with summarizing these different options. Again, this is geared towards, again, based on our experience, we have rarely seen if the customers are starting fresh, the born in the cloud companies. If you're setting up a company, I rarely see that they are going towards the SQL Server route. A lot of customers who have a lot of existing applications, legacy systems, and all those where they have already been using SQL Server, when they migrate to, when they plan to go towards the cloud, that's when the migration is going to be key. So this session is geared towards customers who already have SQL Server on premises, or on even on EC2. So if they're already running a portion of their SQL Server stack on AWS itself, how do you move the SQL Server to a different account? How do you move SQL Server from EC2 to RDS at a later time? So all those things will be answered hopefully in this session. Again, feel free, highly encourage the Q&As and anything that you need to clarify. Just a recap of what was discussed in the earlier session from Raj, and there was also some conversations around what exactly is RDS and EC2. Just to give, again, reiterate the same point, because this is going to be the key, right? So whenever you have any workload on SQL Server, the first question you should ask yourself is it the right fit for RDS? So you look for what are the limitations of RDS. As long as you're not hitting any of those limitations of RDS, that is the best place to start, because there are a lot of features that come with it, where you can focus primarily on your application rather than again, spending time on these day-to-day activities. If that is not an option, that's when you would consider the SQL Server on EC2. So what are the features at a glance? So there are a lot of features that are available in both the RDS and EC2. The first thing the I want to highlight again is why not RDS approach. The first thing that comes is what are the versions that RDS supports. It supports the limited versions, and as long as you're fitting in those guidelines, it's better to do these on RDS. In EC2, basically you can install everything, right? And there are different editions that are supported. And I want to highlight that both the encryption and authentication side, the SQL Windows native authentication and Active Directory integration and encrypting and TDE, these are both available in RDS and EC2. So the RDS has passed through some of the compliance benchmarks. So if you're using any HIPAA compliance, FISMA compliance, and all those. So they have gone through the rigor that as long as you're following the right constructs, like the key management and all this, they can qualify for any highly compliant workloads. So a lot of financial services and healthcare and government agencies have been using RDS for a while. So what happens when you're planning to migrate? So what are the things that you need to plan? What do you do to make it ready for migration? So again, this is the high level steps that we help the customers go through, or the customers if they wanted to do the migration themselves. So the first thing is, are you consolidating your SQL Server overall footprint? So what is the inventory of all your SQL servers and what are their dependencies? How do you manage the authentication and authorization? Is it a common Active Directory that's supporting this? And how does the authentication within the SQL Server happens? Are you using all the features? So again, as I mentioned earlier, it's a lot of customers have been using the relational systems and even higher level systems like the enterprise option within SQL Server just because they have it. Just because it's easier to manage. They may not be using all those features, but start identifying the features that you're actually using. Know your licensing options. So a lot of customers, they come and say, we just renewed, will not renew. It won't expire until the next 3 years or 5 years. So would that mean that if you're going to RDS, you would have to pay license included model? Then in that case, we have seen some customers, for them, just to save on the overall licensing, you bring your own license approach, they're not transportable to RDS. So in those cases, we have seen some customers temporarily run it on EC2 so that they use up their existing licensing. And once it's ready to expire, they migrate it over to RDS with license included model. As I was mentioning earlier, what is your high availability RTO and RPO requirements? What is your retention policies? As you saw in the previous lab, the intent for showing the lab is once you go through the creation process, you will almost understand all the things, all the configuration options that you have, so that you can better prepare what your target solution or system is going to look like. Once you know your target solution system, is it EC2, is it RDS, then that's when you start thinking about how do I move my my data running on premises to the cloud. Once you have finalized your target is going to be either EC2 or RDS, or it's very much possible if you are a SQL Server shop, you may end up with, okay, now I understand that there are probably 30-40% will keep running on EC2 or virtual machines. The rest 60-70% of them can go to RDS. It's again, we have seen a mix of if you have a large footprint of SQL servers. So we see a mix of some databases going into EC2, some databases going into SQL Server for whatever reason, for the cost reasons, for the compatibility reasons. If you're using third-party products, they may not certify running on RDS. For whatever reason, you will see that you may have a combination. So that's the reason assessment is very important. Understanding what options are available and what is the right target platform that you should go with. So going one by one, I wanted to cover different options, right? using S3 as an intermediary for backups, using something called a storage gateway if you have huge amounts of data. And how do you migrate to RDS? There are other options like the Snowball and database migration service. So we will be talking in detail about each of these options. Again, feel free to ask any questions. Either myself or some of our panelists will answer these questions. So what is the easiest way, basic way you do have you do have your on premises? What is the recommended way? What is the best way? So I think whenever you are talking about recommendations and best way, it's we wanted to understand more. What do you mean by easier and best? Because it has an implication. Are you willing to you want the real time replication happens? How much downtime you can afford? As long as you can afford the downtime of shutting down the instance, taking the backup and copying the backup over to cloud and then restoring from the backup, whatever time it takes, if you're okay with that much amount of downtime, then probably this is the safer, easier, better option, because there is no complexity involved. Again, this is similar to what you have been used to when you are recreating your databases on premises. You basically take take a backup and then move the backup to a newer hardware, newer machine, or run non-production instances, and then restore. The process is exactly same. Coming into some of the details of how it's going to work within AWS, right? As you can see, there are some services that this architecture is introducing. One is S3. S3 is an object store. So think of it as a unlimited, infinitely scalable object stores. So you have been used to putting your data into these NAS, SAN drives, NFS drives. So instead of that, you would take the backup into S3. So the easier way to think about it is you can put the content in S3 and retrieve the content from S3, and it's highly scalable, like it's highly performant. And how do you do that in a more secure way, depending on what is your overall enterprise strategy? I think that the one of the earlier poll questions was, do you see yourself as going all in AWS, or you see yourself more like a hybrid? So there are some constructs, networking constructs. How do you enable the network connectivity between on-premises data centers to AWS? There are options like site-to-site VPN, where the data goes over the wire, over the internet, but at the same time you can secure it by using IPsec tunnels. Or the alternative option, which is a better option, preferred option for large enterprises, is the direct connect, where you are actually physically laying a fiber, laying a line between your on-premises to one of the points of AWS data center. There are some ISPs that handle this fiber connectivity, where you're basically laying out, and all the transmission happens securely through this physical fiber layer. And once you put this network connectivity, you can put it in S3, and that's where data from S3, it can be restored. You can use the data sitting in S3 as a backup. You can use the same approach for spinning up an EC2 instance with SQL Server and restoring from the backup, or you can use the similar approach for restoring the backup from an RDS. So there are some secure in transit, said using IPsec tunnel, or the traffic goes through HTTPS, or encryption at rest. So you can have your EC2 machines with the underlying EBS volumes, which is the elastic block storage. You can secure it. Same thing with S3. You can secure it, and all this happens through the backup restore mechanism. And what is the preferred way? In what use cases you would use this approach? As I said, if you're okay with the downtime, depending on the size of your SQL servers, if it's a few tens of GB, hundreds of GB, even few terabytes of GB, as long as you can afford a portion of the weekend or the weekend where it's not mission critical, you can afford that level of downtime. Then probably this is the easier and better approach to go with. I think again, going back to different options, if you are already using existing backups, using native SQL backups, if you're using that, I think whatever you see on the left side, right, the on-premises, you may already be saving this information, having the backups in your NFS share, in your wherever, again, Samba share or whatever share machine that you have, where you're storing tens or hundreds of SQL Server backups, including the other backups. Instead of copying one by one, there is also a solution or service within AWS called Storage Gateway. Storage Gateway, what it does, the difference between the prior one and this one is you don't need to copy backup by backup or .back files by backup onto the cloud. So what this does is, if you have to restore tens of databases, hundreds of databases, even constantly changing, because what happens with the backups in the earlier one is you have to take the backups at that point to make sure you're able to restore. There is no continuous copy of the backups onto the cloud. It's a separate process. So for that reason, AWS Storage Gateway, it's a service. Again, it can come with the hardware, or it can come with a virtual machine. What it does is it ties itself with the NFS drive. Whatever is happening here, it can make a copy of it in the AWS side on S3 bucket. So once you configure this, whatever backups you're taking across the board, across your enterprise, they're automatically copied to the backup bucket. And from there, you can restore the same way as before. You can restore using SQL Server on AWS, on EC2, or SQL Server on RDS. Once it gets to S3, it's the similar approach, but how it gets to S3, this may be a better option if you have many databases. If you already have an existing process to save the backups into your file share. So for those reasons, it's better to use these type of service or solution. Again, giving one more view, right? The other way is, if you have on-premises SQL Server, how do you put the data into S3? So you can use many approaches of saving the data into S3. So what you can see based on the conversation so far, right? S3 plays a key role in anything related to migrations and backups and restores. So even when you're taking in the earlier lab, you saw how natively it automatically takes the backups. So all the backups are eventually saved in S3 as snapshots. Even when you're using migrating from on-premises to cloud, you're primarily using S3 as an intermediary where you're putting that information. The reason S3 S3 is one of the most mature service where you can have fine-grained access controls. So it covers on the security side, and more importantly, it also covers on the performance side. So you can have many, again, we have seen terabytes or by even tens of terabytes of throughput, depending on how your per second throughput on S3, depending on how you structure, there are some optimizations that you can do to make it faster on how to move the data around into S3. So just to give you an example on how S3 file transfer process works, if you have a big file and you want to upload to S3, it automatically breaks it into multiple chunks, and it creates its own separate thread or process, and it splits, and you can have 5 GB per second output, and you can have up to 5 terabytes of individual object. There are some limitations on how big the file can be, but I'm pretty sure if your SQL Server backup or data store is bigger than that, there are ways to split it apart and then move different files. So this may be a faster way. And as I said in one of the earlier slides, Storage Gateway automatically handles some of the performance optimization. So instead of you figuring out how to move the data as quickly as possible, do I need to have 5 threads or 10 threads or 20 threads? If you're using something like Storage Gateway, it automatically handles the optimization portion. Even more if you have an even larger data set. So we did see some customers, especially on the SQL Server side, who have probably tens of terabytes of data, or even if you combine, consolidate all the SQL Server data stores that you have, maybe hundreds of terabytes, or even for a handful of customers, even petabytes of customers. And depending on the region that you are, right? Depending on the region, for example, what we have noticed is in South America and Middle East and some parts of Asia Pacific, the network connectivity may be slower. So in those cases, even the network communication may be even pricier or costlier. So in those cases, there is additional option called a Snowball, where it's a physical device, where basically AWS will ship the physical device to your data center, where you upload it. Think of like export import process. You upload all the files and basically ship it and FedEx it. This is the in cases where it takes time, more than, I would say, a couple of weeks to actually transfer the data that you have, then this service may be a better service, where you're physically putting all the backups and all the information into these physical drives, and AWS will ship it to the data centers, and from there they'll upload to S3 bucket, and from there it's visible on your S3 bucket, and you can follow the same exact process like restoring from the backups. So all the approaches that we have covered, it's basically how to move the data, but ultimately it's using the same process, which is taking the backups, put the backups in some intermediary place, and restore from backups. This is applicable for both SQL Server and S3. So let's see what are the other options of SQL Server migration, right? I think again some options are only available in for the databases sitting on EC2, because some of the if you have if you cannot afford any of the downtime, like what I mentioned with the SQL Server backup. So we'll talk about minimizing the downtime approaches, even when you're going with RDS. But so some of the options that you already may be used to, for example, log shipping. If you have, again, Windows Server failover clusters, always on option. So you can have multiple clusters. You can have your primary sitting on premises. You're building another cluster, failover cluster, that's primarily running on AWS. So in those cases, this acts as a warm standby. It supports the asynchronous replication. So whatever changes that are happening on your on-premises, they're asynchronously replicated to this failover cluster. Even within the failover cluster, as I mentioned earlier, it's better to build for high available architecture. So you would have a replica, you would have a warm standby, and they both are configured using the always on option. And how the data gets moved over, again, it can be using site-to-site VPN or direct connect, which is represented in this diagram. But basically, this option may be more familiar with the SQL Server DBS. This is how you have been doing your on-premises again high availability clusters or disaster recovery. Is the same exact process. Instead of having this solution on a disaster recovery site or another data center or another location, you're enabling this on the AWS side. Again, as I said, whatever you do on EC2, it feels and looks similar to what you have been doing so far. So all the options that you can configure on premises, they're also configurable on AWS. So again, as I said, RDS does not support this because it doesn't support the underlying asynchronous replication protocol always on. But this is an option that's available for using with EC2. Same thing with the database mirroring approach. Again, so you do have the principle, and again, you're basically mirroring the data. You also have the availability groups where you have the sort of primary and secondary. This is probably a more common scenario where on premises you may have the primary and secondary. So this is your first level of high availability disaster recovery option. Even if the entire data center goes down, even the secondary goes down, it may fail over to the SQL Server secondary replica. Again, all the different architectures that you see are different options. Again, which one is the best option for you? This all depends on how you are currently running, what is your RTO, RPO, and how much risk or mission critical your application is. So I'm sharing some of the different architectures experiences with different customers. These are the options that are available, and based on your specific criteria, it's possible that you may have multiple applications, and one specific type of solution may fit with a few subset of your SQL servers, and some solution may fit with a fewer subset. That is the reason overall assessment planning is going to be key. If you have multiple SQL servers, this can tell you how to basically migrate your solution, what is the target solution or architecture is going to be. Moving to the one more option, right? I think that the solution that we have seen after the backups is using the log shipping and always on and Windows server failover clusters. All these are different options. These are primarily available on for SQL Server on EC2. The next one, which is the transactional replication. Again, this is similar to, again, if we have seen some customers who are been running a SQL Server, they also utilize this pub sub mechanism. So you can have the publication database within SQL Server, where it publishes the information to a snapshot folders, and the snapshot agent which will monitor the changes, and it invokes the distribution agent, which basically sends it to subscriber. So this approach is still applicable even when you're migrating to cloud. So you can select a specific database, or you can select some specific filtering criteria of the entire database, where you're only publishing a set of tables and whatnot. The subscription database, in this case, can be an RDS or EC2. So this is going to be the key, which is if you want to have the near zero downtime or a lower time to migrate to RDS solution, this can be a potential option. Again, depending on if you're already using this option on your on-premises database. If you're using publish pub sub mechanism, then your subscriber can be an RDS or EC2. So whatever migration approaches that we have discussed so far is primarily around how do you move from SQL Server to SQL Server. Again, most of them are already familiar with you because we are using the native SQL Server solutions, the backup restore solution, log shipping solution, always on failover cluster solution, pub sub solution. All these are native AWS, native SQL Server solutions. There are other solutions that AWS can bring in. I'm just trying to recollect. There is one more option that I'll probably add, and I shared some of the links after the session, is something called Cloud Endure. So what it does is it takes a block level replication. So you can hook up your on-premises SQL servers. So it keeps on copying these block level replication. It has nothing to do with the database replication. Any change that happens on premises, it actually copied to cloud. And Cloud Endure is a solution that only supports EC2 as the target. So if you want to have a like-to-like with a near zero downtime, and you do not have the enterprise edition, and you do not have any of the options like the clustering and SQL Server mirroring and all that, you can basically copy and replicate your entire machine onto the cloud. That's also an option to consider. So the next few minutes, I also wanted to focus on one more option, which is a relatively newer option, better option if you fit in specific criteria, right? The criteria is you have your SQL servers, and you are considering migrating to SQL Server, but at the same time, you're also open for opportunities. Can this work in an open source system? Can this, whatever system, whatever application that you have currently running in SQL Server, is it possible for me to migrate to MySQL? Is it possible for me to migrate to Postgres or any other purpose specific stores like the Redshift, like the DynamoDB? These are all different stores solving a specific purpose. Is it a key value store, or do you have the analytical workloads? Do you have a transactional workloads? Are you using a lot of stored procedures and all those things? So if you're open for migrating to anything else apart from SQL Server, including the SQL Server, then DMS service is something to consider. DMS is primarily two components. One is what is called a SQL schema conversion tool. The second one is the migration service itself, which actually moves the data. So if you go one by one, right, the schema conversion tool, this is a tool where you can hook up to your database, your SQL Server database, to understand the level of effort to migrate. For example, if your intent is to move from SQL Server to let's say Postgres, is it going to be an easy migration? All the data types that I have, will it be automatically converted? All the stored procedures that I have, can it be automatically converted to PGPL SQL? So this SCT tool will actually try to convert. There is a lot of automation that's involved. It automatically converts the data types. It converts the schema. It converts the stored, even the stored procedures. It highlights the areas where the automatic conversion will not happen. It categorizes into simple issue, medium issue, or complex issue. If it needs some manual effort to actually modify it, because automatically it's not able to convert. So what we have seen from customer experiences is there are a lot of SQL Servers databases that fall anywhere between 70 to 90% of automatic conversion. Again, depending on the number of database objects that you have, I think that's a very high number. And if you fall into those numbers, it's also something for you to think about. If the migrating to SQL Server in AWS is going to be a temporary migration where you can have a parallel project to convert the SQL Server into non-proprietary or open source tools. So once you go through the schema conversion tool, so what you do is it automatically converts the schema, and let's assume that your target is a Postgres or MySQL. You can recreate. So one advantage with this is the same approach can be also used to have to convert to SQL Server. Your target can be RDS SQL Server, and you can move your SQL Server from on premises to RDS SQL Server. But one thing I want to highlight is whenever you're going from like to like, from SQL Server to SQL Server, the way DMS or SCT works is it converts all your schema or data types into a DMS specific data type, and then converts it back to SQL Server. So you may not see the exact like to like. So there is some regression testing required. There is some additional testing that's required, because all your data is being converted to DMS specific data and then converting back to SQL Server. As opposed to in the previous section, we have seen the backups and always on and the mirroring technologies, PubSub mechanisms. It's not converting. It's basically carrying over whatever the SQL Server stores. It's just moving the data from one place to other. In this case, it's actually doing the conversion. So again, depending on the data type, depending on the object that you use, you may run into some issues. If you're using the simple data with all the rows and columns and non-complicated data types, this may also be an option to consider. But this is definitely an option to consider if you're going away from SQL Server. But if you're going into SQL Server and RDS, this is definitely one more tool in the toolkit where you can use accordingly if it fits your purpose. So the way it works is it also has this concept of change data capture. So whatever changes that you're doing on SQL Server, the replication instance, which is part of the database migration service, it'll read for all the changes and publish the changes. So it supports many configurations where you can have one-to-many. One change can be replicated across multiple databases, multiple RDS. Many databases can be grouped to go into a single database, or many to many. So the different configurations that it supports. It also supports the initial data migration, the full loads, or it can also support the incrementals, which is the delta migrations or change data capture. So it opens up a lot more possibilities when you're actually migrating your SQL Server stores. This need not be only for on-premises to cloud. I think one of the questions during the poll I also asked, this can be between AWS to AWS. This can be between Azure to AWS. This can be between on-premises to AWS. So you can hook it up as long as there is connectivity. You can point your source and send it to target. And again, there is as I was mentioning, that the homogeneous or heterogeneous, you'll keep listening to like versus going to open source. Those are heterogeneous data migration. If you're migrating from SQL Server to SQL Server, whether it's EC2 or RDS, you can use DMS, and so is for the different flavor. If you're migrating from SQL Server to other ones. So again, one key thing to highlight is the SCT tool automatically converts your again stored procedures, your schema. So highly recommend, even if you're migrating or not to these open source data stores, highly recommend to run the SCT on your existing SQL servers. So understand the level of complexity. Is it something that that's going to be an easier project? Do you want to do a two-step approach, where migrate to AWS on SQL Server and then do this replatforming? Or is it, if it's easy enough, then you can skip the first step of migrating to SQL Server on AWS, where you can directly go to these target data stores. Just to summarize, uh, which uh, uh, which migration method you would use? Again, I said this is a summary of all the discussions that we had. Would you use a backup restore approach? Would you use a transactional replication, or always on availability groups? Using log shipping or DB mirroring, or would you use the DMS tool? Would you use Snowball to migrate all these different large amounts of data? So I think that the different dimensions that you need to understand is what is the type of SQL Server that you use. Are you using standard, enterprise, and so forth? And as you can see, for RDS SQL Server, the key thing to note is it supports for backup restore and transactional replication. It doesn't support the log shipping and always on and DB mirroring, but it does support the SCT and Snowball. So I would always start with what is supported in RDS SQL Server, as long as it fits within your requirements, the limitations that you have, or the RTO and RPO, and the overall SDLC process, whatever that is, as long as it fits, this is the place to go. And if it doesn't fit, then the fallback option would be the EC2. Just to summarize the overall migration considerations, always look for the SQL Server version and edition feature. So there's a lot of times where you may be using a SQL Server specific edition, but you may not be utilizing its features. So we have seen that over and over. There is a cost optimization that can be done right there, where again, recently we have done at a customer, where they could have used the Express or the web edition, and they used enterprise edition so far, and they did not use any of those features. So what we did as part of our migration effort is to downgrade the edition that they're using, because all the features that they were using, they were working as is. So utilize the opportunity to understand what your application does, and if you're utilizing these features, and try to understand so that it has an implication, whether you can run it on RDS or SQL Server, and what is the implication around the bring your own license versus licensing period models. The next one is the authentication requirements. Authentication authorization is going to be a key consideration. Again, historically, traditionally, that we have seen, it integrates with the Active Directory for some of the authentication. When you're migrating to cloud, so depending on if you're a hybrid cloud customer or just all-in cloud customer, there are different options on how you integrate with your Active Directory. It's possible that you may end up in a situation where you do have some servers on premises, you do have some servers running on AWS. Do you want to go back to your on premises for each AD integration, or do you want to have a copy or connector within AWS where it primarily uses as a federation or a copy of your existing AD, so that the connectivity between AD and SQL servers happens locally within the cloud. Also consider the amount of data being migrated. So whenever you plan for this project of migration, consider the data, how much time it takes. Consider if you are going over the internet while using a site-to-site VPN, and whether you're using a direct connect. So direct connect can support high volumes of data movement, anywhere between a few hundreds of MB per second to few GB or tens of GB per second. You may not have that much high bandwidth within if you're using an internet line. And also do consider the timeline, because even if you are a big enterprise or wanted to go to AWS and put up direct connect, there is typically a lag. It takes anywhere between 1 month to 3 months or even longer, depending on your negotiations with your ISP. Also do account for the time if you're planning to go to the direct connect. So the migration method, be open for using the multiple migration methods. So the key here is assessment of your entire fleet of SQL servers. Don't try to narrow down using one migration method for all. It's better to use the migration approaches based on what is relevant. So what we have done or what we experienced is categorize into these multiple work streams, saying these particular 5 databases, 10 databases that can afford a longer downtime. So let's use the backup method, because there is no complexity. It's a path of least resistance, and any of your team members can do it. So same thing with the higher, if you're planning to go for heterogeneous data stores, at least I would recommend considering SCT and running the report and viewing the report. And again, AWS and partners. So one of the things that I want to highlight or cannot highlight enough is the help that you could get. You are not alone in this journey. So again, we as partners can definitely help. AWS has a lot of different teams depending on where you are with your journey. If you're already running workloads, there's a different team that handles. If you're planning to migrate, or if you're just considering, there are different teams. There are some specialized teams specifically focused on helping with SQL Server, specialist team who are focusing on the infrastructure side. So definitely ask for help. Again, it's a lot of times there are a lot of funding programs available. I also want to take this opportunity to highlight a couple of things, right? There are some funding programs available if you're on premises and wanting to go to cloud. So depending on how big your AWS spend is going to be, there are different programs. Again, it may range. We can have further conversations on what type of funding help you may have. It not only get created on the AWS spend, there are also some programs available where you can have a partner like us to do the actual migration, to do the POC. So definitely willing to hear any of your use cases to further the conversations. Let's connect and see, understand what your existing situation is and how AWS and us as a partner can help you with your journey. So the other one I wanted to highlight is a well-architected framework. Again, this is more of a generic framework across any application. This is not specific to SQL Server. But anything and everything that you architect and deploy on AWS, there are primarily 5 core pillars of how you make your application, and it's included as part of the well-architected framework. Again, which includes the security side. Make sure that security is your highest priority. But how do you make it easier with the performance, resiliency, operations, and cost optimizations? These are the other pillars, right? So for everything and anything that you try to spin up, model, architect, make sure that you answer yourself against these 5 dimensions. And this is also a place where, again, as I keep reiterating, AWS is there to help. We as the partners are there to help. And optimization is a continuous process. So again, a lot of times, depending on the time constraints, resource constraints, budget constraints, some customers choose to move as quickly as possible. So they also incur the technical debt. So we have seen some customers where migrate to EC2 as quickly as possible, and at later point of time migrate to RDS, and at later point of time look for reserved instances and cost optimizations. And at a later time they said, okay, let's try to use some of the features, and let's try to migrate from SQL Server to somewhere else. So all these are different steps in the journey. Whether some customers take the 4th step right away, or they go through the sequential steps, anywhere you can plug in, try to understand the implications. What are the trade-offs based on the decisions that you're making? Any questions? Again, I want to open up for any Q&A. I think we do have some of the team members can unmute themselves and ask. I want to make it as interactive as possible. And after 5-10 minutes, I will start opening up for labs. So if you have any questions, please unmute yourself, and you can pose any questions. Okay, so I think we can proceed to some of the labs, and we can have the conversation going. So I'm stopping the share. Raj, can you share the next lab session?
Let me know when you can see my screen, guys.
Yes, Raj, we can.
Okay, perfect. So this is the agenda. The link and everything remains the same. If anyone has lost the link, let me know. I can paste it again. Or let me do it anyways. This is the link for the lab. This is the code, but it should not ask you for the code again. And I'm going to share link to the event engine again. Okay. So again, we are focusing on backup and restore, and then securing RDS SQL Server. Any question, anyone? Anyone? Is everyone okay with the information? Do you need anything? Please raise your hand. Okay. If you are able to re-log into your dashboard or AWS console, can you raise your hand so that we know that you're good? Okay, sounds good. If you run into any issues, any questions, please feel free to ask. Thank you.
So I'll start sharing some of the running commentary, right? For the backups, I want to give a high-level overview of what this lab is going to do. As I was mentioning, one of the key features of using a service like RDS is it takes away the day-to-day work related to many things. Backups is one of them. So I do, again, remember the days when the backups were not working, the disk space was full. and it got backed up, and there are tons of us databases were trying to take the backup at the same time. The performance was slow. So all those issues will not be there if you are using these type of services. Again, people, especially the DBS, will be more relieved if you're using a service like this. So the way it works is, as I was mentioning earlier, when during the creation of the database page, you basically can configure how your backups are going to be. By default, I think it takes backups for 7 days, but you can enable up to a maximum of 35 days. So one of the common question that we do get asked is what happens after 35 days if we need to save for 6 months or 1 year for our compliance reasons. You can still do that by taking what is called a manual backups. So this particular lab will also walk you through on how to take the manual backups. And you can also select a backup window. So backups are done during that backup window that you mentioned or configure. And so one thing to highlight is, uh, will the backups will have any performance impact for what I'm doing? Uh, Again, this is where I would say that the production template that you have been using, if you're using a multi-AZ environment, so start taking the backups from the standby node, so you'll not see any performance degradation. And each backup is called a snapshot. You can see whatever the available snapshots are, so that whenever you're using the restore, you can select which snapshot that you want to restore from. And one key advantage with this is, once you take the backups, you can share this snapshots to other accounts. Again, the use case here is, in a lot of times, the AWS account for your production may be different from non-production. So you only wanted to give the read access to different teams. So you, for whatever reasons, if you want to share this backup to somebody else, whether it's internal consumers or external consumers, you can give the backups permissions, and it integrates with the IAM, where you can IAM is Identity and Access Management Service. You can say that only this particular group or team or user can access this particular snapshot. The key advantage, especially when I myself started using the RDS service several years ago, is how easy it is to restore to point in time. So you have all these backups. You can basically have a consistent restoration, uh, where you say, I wanted to have the data as of yesterday at 12 o'clock in the afternoon. So because anybody coming from the traditional legacy DPA environment, so you would have the scripts, you would have all these, and you want to make sure all your parameters and attributes are correct. If you're lucky with automation, if there is no automation, every time it's a struggle, which is restoring to a point in time. How do you make sure you apply the log files? How do you make sure you apply all the archives correctly, in what order? So all those things, it's taken away by selecting a particular snapshot, and you specify the restore point in time. This gives additional dimension of the overall operations. So you can have, if you have a production system running, you can have a point in time restore with a different name. So you can have your other than production environments, you can have multiple production environments that is running by delay, whatever your need or use case may be. The point in time recovery is one of the key features that's available across all RDS instances, including the SQL Server. And it also integrates with one more service, which we are not covering as part of this lab, is AWS backup service. So again, this using this service, you can consolidate backups across different places because eventually in a typical enterprise, you may have you need to back up your databases, which are RDS. You need to back up your virtual machines, EC2 machines, whether it's a application server, web server, or you may have some databases running on EC2. So all those things, you need to have one place to consolidate as a backup, because the retention may be applicable for different groups, and you need to take the backup as a group together, not necessarily individually by specific service. For that AWS backup service, we can use it to group and consolidate the backups across multiple services. So the next part of the lab is to take the native backup to S3. I think this is the lab where you will also look into how S3 works, how do you create a bucket, and how do you point out your backup option to S3. So you'd also play with the option groups. I think when you're creating the AWS RDS database, there's an option, default option that you've selected. So you can include the options here, and you specify the bucket where it needs to copy. And there are additional attributes like encryption and when do you want to do that, and all those. So once you select, it can take the backups. So you can use the SQL Server Management Studio to start taking the backups, because once you configure, which you have given as part of the database options, save it to this particular location in S3. And once you do that, you're able to save that data or backup within S3. And you'll also be looking into restoration options because the data is saved in S3. You can use it to restore the database by pointing to the same location. So the first part of the section of the lab is basically the backup and restore using the RDS method, the AWS method. The later part of the backup restore section or lab is using the native SQL Server backup and restore method by using S3 as an intermediary backup. Hopefully that gives an enough overview of what the lab is about. So I'll give some time for the team to go through. So quick check on how things are. So can the folks raise their hands if they're able to progress? And no issues in the backup recovery section. If somebody is stuck with the earlier session by spinning of the database, just do let us know. We can help you out. So let me also give you a brief overview of the security portion that you'll also be doing. We did not include, again, considering the time, we did not include all the specific sections, but I want to reiterate that the labs will be available for next several hours. So even after the immersion session is over, you are free to continue with the labs. Again, as I said, you can complete the entire workshop if you choose to. But for the scope of today's immersion session, we want to make sure that you are at least aware of the options around encryption in transit and at rest. I will give you a brief overview of what is covered in security, so that again, consider security as a first-class citizen. Make sure that anything and everything that you do on AWS side, you follow the right security best practices. So the first thing that you need to be aware of is you need to understand what is the VPC, how the network constructs work, the subnets and internet gateways and private gateways, what makes it a private subnet, what are security groups, which are the firewall rules. Getting used to of a different construct is going to be incredibly helpful. I wanted to also share that again, typically these type of information is handled by the networking team at a lot of different places. But even as a DBA, even as a developer, even as any person working on the AWS environment, These are base fundamentals that you need to be aware. You may not get you may not be creating these VPCs and subnets in the customer side in real life. But usually these are handled by the shared services team, and once they create, they would give that information so that you can plug it in here. So the next section is around identity and access management. This gives you an overall view of how the authentication and authorization works in AWS. What are users, what are roles, what are groups, and how you can assign policies or roles. There are some pre-built roles that are already there. So I think with this identity and access management, you'll get some idea of how, when you need to be a database administrator, what type of role do you need to have? What are the things that you're allowed to do and what you're not allowed to do? Are you allowed to, if your organization has a separate backup team, has a separate storage team, has a separate operating system team. So which team gets what type of permissions and policies? Or is it the right time to actually move away from these different siloed groups and call them as the shared services group or specific database specialist group, or whatever your organizational structure was and whatever organizational structure is going to be going forward. So this IAM is going to help. Again, IAM, there is a lot more to IAM than what you see in the lab. It can integrate with your Active Directory, get the roles federation and all this, but this gives you an overall idea of what a role is, what a policy is, and how the users get access to whatever they can see. One key thing, especially for specific to SQL Server, is how do you integrate with your, how do you use the Windows SQL Server Windows authentication? How do you enable that? I think even during the creation of database lab, we were seeing to enable the checkbox. At that time, we did not. So you can specify, you can modify. This also gives you an idea of, once the database is created, what are the options that you have for modifying an existing running database? What are the things that you can do online while the database is up and running? What are the things that you need a restart for the machine? So again, it will open up some of the possibilities on how to integrate your SQL Server to Windows authentication. And how you can apply immediately versus delaying it until a maintenance window. So coming back to database data encryption at rest and at transit, you'll get into some more details of the KMS service, the key management service, which I was sharing earlier. And you also have an option to perform transparent data encryption, the TDE. And the way you start it, it's similar to what you are used to by adding an option in the parameter file. Here, the way it is it's managed through adding an option as a configuration option. Once you enable that, you can specify the key, and you can validate if the encryption is working or not. When it comes to in transit, again, this is also a parameter that you can set where you're forcing an SSL for any communication through whatever JDBC, ODBC connectivity. So any connection that's coming in, it can enforce the SSL. And once you make the changes to your parameter file, you can save it, and you can see it working in action. Again, for compliance reasons, we want to make sure that at least for your production environment, you enable auditing so that, again, you have a trail of what some of the administrators are doing and how again, this is the auditing option is also a SQL Server native option. And you can specify an S3 as a placeholder for writing your audit file. And this satisfies some of the compliance requirements that you may currently have going into the cloud. So that covers the security portion. Again, there are, as a bonus, you also have the performance monitoring and scaling and optimization. How do you how do you increase the storage? How do you increase the compute, changing from one instance type to other instance type? How do you add read replicas? When you're performing the monitoring, how do you use CloudWatch? And there are also some options around enhanced monitoring. Does it need to collect every minute versus multiple minutes? How do you configure your own custom alarms? How do you get notified? What happens within the database using performance insights? So all these options are there as part of the workshop. Again, feel free to continue with your process of learning and going through the labs. Even if you're stuck after the immersion session, you do have our email addresses. Feel free to reach out, and we can help you out post the session. And last but not the least, I also wanted to share one of the surveys that we are looking forward to ways to improve. So again, I would highly appreciate if you can take a few minutes to go through the survey on our areas to improve. How do you feel about the current session, so that we can improvise as we go further. So I pasted the survey link. So again, we'll be here for additional half an hour or so. So whenever you get time, please open the link and fill out the questions, and also do recommend us the ways to improve. Again, we're all learning in terms of how do we transition from conducting an in-person immersion days to make it more interactive, to make it more useful for the attendees. So we are looking for ways to get your feedback on what would be an ideal session for something like this, so that we can improvise. And just to note that once you click and submit, if you put the same link, it will expire. So you only have one opportunity for each of the participants. So I'll also open up for general discussion. So if you have any specific blockers, challenges, why you're not able to move your existing workloads to SQL Server, if you attempted to move, but you're facing some issues, or even how to even get started, what is the cost benefit, and how do you do the assessment, so we can have the discussion. If you're willing to share your existing situation, we can happily have the conversation so that it can benefit the rest of the team members. So let us know if you're able to proceed to the security section. Please raise the hands if you have completed all of them, or any questions. So just a reminder, please do share the survey. Please go through the survey and share any feedback. I'm pasting the link again. I'm sharing an email link so that if you have any questions post the session, feel free to reach out to us for any help with the current labs, or for any help that you may need at your enterprise company for any guidance. So we can definitely involve the AWS team and ourselves to help you guide with your journey. So I also want to take this opportunity for thanking everyone, every participant. I think it is engaging. I see a lot of questions back and forth, and again, we hope that you are able to go after this immersion session with a little bit more knowledge on how to run the SQL Server in AWS, and appreciate the overall services that AWS has to offer, and solidify your thinking of migrating to cloud with different types of workloads.
Thank you, Lakshmi and Raj, for the great session.
So we'll keep the line open for another 5 minutes, and thank you so much.
Thank you, everyone.
And just before we start, I want to remind you one more time, please do help us become better by filling out the survey. and again, looking forward to the future sessions.